For thousands of years, the nature of the universe was the purview of philosophers, although the debate took many forms. Pythagoras, however, the ancient Greek father of mathematics, believed that mathematical principles were what governed the universe first and foremost, while elsewhere, the ancient Egyptians created the first 365-day calendar some 5,000 years ago based on astronomical observations. In Mesoamerica, Mayan astronomer priests also used astronomical observation for an accurate and reliable calendar setup. Even centuries and millennia ago then, humankind was already trying to crunch the data of the stars into something comprehensible on the ground. Cosmology and physics then arguably began as offshoots of philosophy and theology. And though Newton and Kepler were working on universal laws of physics as early as the 1600s, modern cosmology really turned it up a notch, beginning in 1917, with Einstein's theory of general relativity applied to space as a whole. Here is when physicists and mathematicians first truly began to consider not just how the universe works, but also how it might end. The philosophy of yesteryear was giving way to the theory for the future, and as it stands, there are 5 major cosmological models: the Big Crunch, the Big Bounce, the Big Chill, the Big Rip, and the Big Slurp. But given that light takes time to travel through space, we know that whenever astronomers look at the stars for whatever reason, they're also looking backwards in time. So before they and we can understand the universe's endgame, we need to understand how it likely came into being. Working in the early 1900s, Albert Einstein famously believed that light was the single great universal constant, that it had a fixed speed and that nothing was faster. Einstein also believed that space and time were inextricably linked in what he dubbed the space-time continuum. For a decade, Einstein worked to incorporate gravity into his models, which led to his expanded theory of general relativity. And again, this is something of a cornerstone of modern cosmology. One problem with Einstein's ideas, however, was his seeming assumption within them that the universe is static and of finite size. Several years after he published, 2 other scientists put that assumption to bed: Georges Lemaitre and Alexander Friedmann. Lemaitre in particular, and focusing on the observable movements of nebulae, concluded that the universe was, in fact, expanding. Working backwards from there, he found that it may have begun expanding from a singular point, which he then called the primeval atom. Then came Edwin Hubble. Hubble still ranks as one of the most influential scientists of the 20th century, as his observations between 1930 and 1960 revolutionized our understanding of the universe again. He discovered that galaxies, visible via telescope, appeared to be moving away from each other, confirming Lemaitre's math. But he was also able to calculate that the universe likely began in a state of extreme density about 13.787 billion years ago. Then, as it expanded, its density reduced. Today we call this the Big Bang model, still the most widely accepted explanation of the origins of the universe. And thanks to Hubble's discoveries, even Einstein abandoned his notion of a static universe. So with the Big Bang as a generally agreed upon starting point, cosmologists now had firm footing from which they could develop theories for the end of the universe too, and questions of shape and substance came into view. For example, we know that so much of the end of the universe depends on its density. Since the universe is full of matter, and all of that matter exerts gravity on itself, how it behaves is our guiding principle. In one variation, a high density of matter is the foundation of a closed universe. Here, it's predicted that the force of gravity leads to a curved shape in which the rate of expansion will gradually slow over time. Then, perhaps, it would stop altogether and transition to contraction instead, which would then accelerate too, gathering speed as all the matter of the universe grew closer together and the forces of gravity increased. In this scenario, all of existence will finally collapse into a single point in a mirror image of the original Big Bang. This is what is known as the Big Crunch model, our ultimate fate of the universe, number 1. There is a question that logically follows, though. What happens then? Ultimate fate of the universe number 2 is known as the Big Bounce. And the concept is quite simple. The universe is in a potentially infinite cycle between Big Bang and Big Crunch. Advocates argue that while we are observably in a period of expansion right now, it's possible that we're not in the first period of expansion ever to take place. We could in fact be at any point in a potentially infinite sequence of Bang and Crunch universes. We could just as easily be living in universe number 5 billion as in universe number 1. Perhaps there's something romantic and almost zen about this particular model. a cycle of birth, death, and rebirth. It's reincarnation on a universal scale. Neither the Big Bounce nor the Big Crunch are prevailing theories in cosmology, however. Since the 1980s, and thanks to rapidly improving technology, scientists have made major breakthroughs in the observation of the cosmic microwave background, or what's often referred to as the afterglow of the Big Bang. Essentially, by applying trigonometry, scientists have perfected how to measure temperature fluctuations in CMB, which in time has led to another conclusion that the universe appears to have almost no curvature whatsoever, which then would seem to indicate that the universe actually won't contract at all. Instead, a relatively flat universe is likely to expand forever. This changes the picture somewhat. In an infinitely expanding universe, the rate of that expansion is what informs ultimate fate of the universe number 3. If the rate is constant, the most likely scenario is known as the Big Chill. A more illustrative name is heat death. It says that as celestial bodies and particles spread further and further apart, infinitely so, the universe will continue over a very long stretch of time to cool. Particles and objects will eventually find themselves too far apart from one another to exert forces upon one another, and the universe will approach thermodynamic equilibrium at extremely low temperatures. What does this mean in simple terms? It means that physical and chemical reactions will no longer be possible. The universe hits maximum entropy. For all intents and purposes, it will have simply died in a state of frozen, infinite silence. What makes the Big Chill particularly chilling, however, is that it today ranks as the leading theory of all of the end-of-the-universe ideas. Still, more than only the Big Crunch and Bounce, there are other contenders to the mantle, and one that's a little closer to the Big Chill, but also quite dramatically different. Because if the rate of universal expansion isn't constant, and also isn't slowing down, then that means it's accelerating. This provides a new basis for another scenario, ultimate fate of the universe number 4, the Big Rip. There have been numerous models and experiments to support this, including one in 2015 led by a team at Vanderbilt University in the US. In general, the idea is that dark energy, which theoretically makes up 68% of universal mass, is in constant battle with gravity. And this is significant to the point of it eventually being fatal. Here, it's proposed that universal acceleration will one day push dark energy to a point, in approximately 22 billion years, where it could literally rip open atoms. At that moment, everything, from the largest star to individual particles to time itself, would be literally torn to shreds. There'd be nothing left. The universe will have essentially been stretched and stretched and stretched until it broke forever. And yet, our final scenario, while unrelated to all the others, is still probably the most terrifying of all. While all other possible apocalypses are at least long-term prospects, occurring billions of years in the future, ultimate fate of the universe number 5, the Big Slurp model, could come to fruition at literally any moment. And concerningly, there is science enough to back it up. In short, all systems in physics naturally move from a state of high energy to a state of lowest possible energy. With quantum fields, this is called a vacuum state, kind of like a final destination. But with one particular quantum field, the Higgs field, it alone appears to be in a false vacuum state. It isn't at its final destination. There's change still to be had. Though it presents as stable, scientists believe it to have attained that stability before reaching its lowest energy conditions. And if true, this means that it could slip into a true vacuum state at any moment. It's heady science, but why does it matter? Well, it matters because it would probably result in the violent destruction of all or most of the universe, and quickly. Even if just a single minuscule point in space collapsed in this way, it's thought that it would push a rippling bubble of vacuum decay through and over everything across the entire universe, ruthlessly cruising through reality at the speed of light. In truth, nobody knows for sure what would occur inside that bubble if it did materialize. It could destroy all matter in existence. Alternatively, it could completely rewrite the laws of physics and nature as we currently know them. But whatever it did, the universe would be so changed it would be unrecognizable. And again, it could theoretically happen at any time. Perhaps before you even finish watching this video. For now, and just as we've always wondered about the beginning of things, there's clearly fascination and foreboding in how it will end. Fire or ice, a shout or a whisper. Math and scientific observation have brought us closer than ever to knowing the truth. Currently, the leading consensus is that it ends in ice, far into the future, most probably via the Big Chill. But who knows? Because on the other hand, there's some reason to think that reality as we know it could be rewritten at any moment. What do you think is most likely?